A rectangular pool with a concrete path surrounding it is shown in the diagram. All measurements are in metres. For part A, we need to give an expression that could be used to determine the area of the pool. As the pool is a rectangle, we know that its area is going to be equal to the length of the rectangle multiplied by the width of the rectangle. Therefore, our area is equal to the length, which is x plus 2. So we have x plus 2, and then it's going to be multiplied by the width, which is x. So if we expand that out, we get that the area is equal to x squared plus 2x. For part B, we want to give an expression that could be used to determine the area of the path. So the path is all the white area enclosed around the pool. So what we can do is we can get the area of the larger rectangle and then subtract away the area of the pool, and that remaining area will be that of the path. So what we need to do first is work out what the length and the width of the larger rectangle are. So this here is the length of the larger rectangle, and it is equal to the x plus 2 plus 3 plus 3. Therefore, in total, we have x plus 8 as being the length of this rectangle. The width then is this length here, and it is x plus 2 plus 2, which gives x plus 4 as its total length. Therefore, the area of the path is equal to the area of the larger rectangle, which is length by width. So we have x plus 8 multiplied by x plus 4. And then we need to subtract away from that the area of the pool, which is x squared plus 2x. So that's what we found in part A. So if we expand this out, we get that the area is equal to x squared plus 12x plus 32. Subtract x squared, subtract 2x, and that's found by distributing the negative sign through that bracket. Then we can see that the x squared and negative x squared will cancel. So for the area of the path, we're going to be left with 12x subtract 2x gives 10x, and then plus 32 is still there. So that's an expression that could be used to determine the area of the path. So for part C, a pool blanket is made to cover the pool. If the area of the blanket is 80 meters squared, use the expression from part A to determine the dimensions of a pool. So in part A, we found that the area of the pool was x squared plus 2x. So we know that x squared plus 2 times x is equal to the 80 meters squared in the question. Now, to solve a quadratic equation, what we need to do is get all terms onto one side of the equation. So to do that, we're going to subtract 80 from both sides of the equation. Therefore, we will have x squared plus 2x subtract 80 is equal to 0. And now, in order to solve a quadratic equation, we need to factorize it. So we can express this as x subtract 8 times x plus 10, and that will be equal to 0. So that factorising step was found by looking at the factors of negative 80 that added up to 2. So we use negative 8 and 10. So using the null factor law, we can say that x minus 8 could equal 0, or we could have x plus 10 is equal to 0. Now these are simple linear equations. We can just add 8 to both sides of the first equation to get x by itself. Therefore, we find x is equal to 8. And for the second equation, we can subtract 10 from both sides to get x by itself. And doing that, we find x is equal to negative 10. However, x is equal to negative 10 is outside the domain because x is a length and lengths must be greater than 0. Therefore, if x equals 8, x plus 2 is 10. So the dimensions is 8 by 10. For part D, it says, if x is equal to 10, use the expression from part B to determine the area of the paving that surrounds the pool. So using the second equation, we have that the area is equal to 10 multiplied by x, but here we're told that x is equal to 10, so we substitute that in, and then we plus 32 on, and then if we evaluate that, we get 10 times 10 is 100 plus 32, which is 132 meters squared, as being the area of the path surrounding the pool.